Welcome to Accelerated Engineering. My name is John, and this is the video encyclopedia for the BINOM.INV function, or the binomial inverse function. So what the binomial inverse function does is it answers the question, what is the smallest number of successes that I would expect with a given probability for a number of trials with a given probability. Let me try and explain that better because it's hard to get the words around it. So let's say I have a system where I'm flipping a fair coin with 0.5% probability of flipping heads. Sorry, 0.5 probability, 50% heads, 50% tails. I'm counting heads as a success. And I'm going to flip my coin 20 times. I would like to be 80% sure that I guess the right number of successes, or the right number of heads. So what this asks is, what number should I guess to be sure that I get 80% heads or lower, and my answer is included, and it says 12. What that means is that if I flip a coin 20 times, there is an 80% probability, or 0.8 probability, that I will get 12 or fewer heads. Let me say that again. If I flip a fair coin 20 times, there is an 80% likelihood that I will get 12 or fewer heads. If I made this a non-fair coin, let's say only a 0.4 chance, we would expect that number to go down since the whole curve shifted. It's likely that I will succeed fewer times. And if my coin is a 0.4 or a 40-60, so it's more likely to flip tails, heads is a success with 40%, and I want to be 80% sure that I guess a number lower or including then it would say 10. So a good way to think of this is, imagine that you're playing a game with a friend where you flip a coin 20 times and count the heads and count the tails. You have to guess a number. You pick a number, and then your buddy picks either higher or lower. So for example, for this to be fair, and if let's say if he guesses, if you guess too high, then he wins, and if you guess low, then you win. Okay? This is a calculation for the number that you should guess. So for a fair game, say, yeah, this makes sense. You flip a coin 20 times, you would expect that you're probably going to get 10 heads and 10 tails. 10 would be a fair place to guess. You get lower, you win. That's this whole area underneath this this orange line. Anything sort of to the left-hand side of that intersection. And if you flip more than 10, then your buddy wins. I think that's a good way to think of it, or at least that's a way to think of it. Basically, it does the opposite thing of the binomial distribution. Binomial distribution, which is shown here, says, what are the odds of getting exactly 10? Or the cumulative one says, what are the odds of getting 10 or less? This is trying to do the opposite. It says, if I want to be 50% certain, I'll go down till we get 50% or just above 50% and say how many trials are that. It means that I'm 50% sure that I'm going to get 10 or fewer. And that's 10 or fewer successes. And that's it. I want it to be 0.9. It says that if you do this for 20 flips, that 90% of the time, 9 times out of 10, you are going to get 13 or fewer heads. And that's kind of neat. So related functions to this, of course, the BINOM.DIST, binomial distribution function, the binomial distribution range, if you wanted to calculate for a range of values instead of just, that's a different thing altogether. Never mind. Anyway, this concludes the video encyclopedia entry for the the binomial inverse function, BINOM.INV. Please take a moment to click the like button, leave a comment if you want, and subscribe if you want to see more content like this. Thanks for watching. Happy excelling!